The fragment fell on a Tuesday. No one on Earth saw it with the naked eye. The main body of 3IAtlas was already past its closest approach, trailing a long, pale tail across the dawn sky. Telescopes still watched it out of habit. One of them, a modest automated survey scope in Arizona, caught a tiny flare near the edge of the coma. A speck detached. It glowed, then went dark. Its trajectory did not follow the dust. It bent inward, straight toward the moon. At the same time, a small lunar orbiter picked up something odd, a brief, hard flash on the night side, a pinpoint near the rim of a mid-latitude crater. No radio burst, no debris cloud large enough to register in detail, just a sharp spike in light, and then a new, fresh spot in a landscape that had not changed in millions of years. The software flagged it. Impact, uncatalogued object, priority medium. Within an hour, 3 different teams had run the numbers. The path back traced to the same source, 3I/Atlas. There happened to be a rover not far from the impact site, not close, but close enough. A compact, 6-wheeled machine the size of a golf cart, crawling slowly across the Gray Plains on a long-term geology mission. Its cameras were dusty, its wheels were worn. It had been expected to die 2 months ago. This gave it a new job. New coordinates appeared in its queue. Change course. Head for the fresh crater. The estimated time to arrival was 12 Earth days at best speed. On the other side of the world, in a brightly lit control room, a different group of engineers saw the same impact alert. They did not own a rover on the moon. They did, however, have a nearly ready micro-rover in a clean room and a small lander module sitting on a launch pad, manifest as a technology demo with a flexible schedule. The impact gave them a target and an excuse. In 48 hours, after a frantic round of signatures and fuel checks, the small lander rode into the sky on the back of a light rocket. Its mission was simple on paper: land near the new crater, deploy the micro-rover, get there first. The old rover trundled on, its path a long arc over broken ground. It could not go faster without risking a wheel fracture. Its operators watched its projected track like a race commentary. The new mission had the advantage of speed, but the disadvantage of risk. The lander had to execute a precise descent into rough terrain. Fail, and it would scatter parts across the moon. Succeed, and a fresh, agile machine with full batteries and clean optics would roll out ahead of its older rival. Human nature turned it into a silent competition. No one said the word race. Everyone thought it. The lander came down 3 days later. Dust plumed silently as its small thrusters fought lunar gravity. Cameras streamed gray rock and shadow into the mission control screens. There was no time delay large enough to make it feel unreal. The lunar surface rose to meet the metal legs. A small bounce, a tilt, then stillness. Telemetry stayed green. A cheer went up through muted voices and tired eyes. The hatch opened. The micro-rover rolled out on its 4 narrow wheels, lighter than a person, but carrying instruments more advanced than any that had touched lunar soil before. The new crater lay on the inner slope of an older one. Its rim was sharp, its interior dark. The micro-rover drove toward it in small bursts, stopping to scan for hazards. The low-angle sun cast long, deceptive shadows. To its left, on the far horizon, a faint glint marked the slow approach of the veteran rover, still days away. Operators joked that the old machine looked jealous. The micro-rover ignored everything but the coordinates and the commands. It reached the rim 5 hours after deployment. Down inside, the camera saw something that did not belong. The object sat at the center of the impact scar, half buried in powder. It was roughly the size of a human head, not jagged like a rock, not pitted like a meteorite. Smooth. Almost perfectly smooth. Its surface was black, but not like basalt. It reflected the weak sunlight in a way that made it look wet, even though it was sitting in a vacuum at 200 degrees below freezing. Around it, the regolith had melted and then refrozen into a glassy ring. Whatever came in had hit hard and fast. The micro-rover halted, and for a moment, all of Mission Control did the same. Every visible panel showed the same image. A black sphere in gray dust, shining like a dropped bead of oil, in a real crater on a real moon that until today had held nothing but ancient scars and human junk. The instructions were clear. Do not touch until the readings are in. The laser rangefinder pinged the object. The distance came back steady. The temperature sensor fired. The object was colder than the ground around it, as if it had not been warmed by impact at all. They tried a gentle prod at a distance. The rover extended a small arm with a stubby probe and tapped the surface of the sphere lightly. There was no motion, no crack, no change. The sound sensor registered only the faint vibrations through the arm. In the control room, someone exhaled loudly. First contact and nothing exploded. That counted as a win. The next step was the big one. Use the main manipulator to grab the object, lift it out, take samples. The risk was obvious. If it broke, that was it. If it did something when lifted, that was unknown. But the chance to bring it into shadow, to examine it in more detail, was worth it. The manipulator arm unfolded. Joint by joint, it extended over the crater rim, down toward the sphere. The claw was a three-fingered grip, designed for rocks of irregular shapes. It did not quite know what to make of an almost perfect ball. The operators inched it in. One finger touched the surface first. The telemetry spiked. Not an explosion, not a shock, just a sudden flood of data in channels that were supposed to be quiet. The arm had no microphone, yet the system reported input. The cameras blurred for a fraction of a second and refocused. The sphere changed. It did not melt or crack. It unfolded. Lines appeared on its surface, glowing faintly in the ultraviolet and near infrared. To normal eyes, it was still black, but to the rover's sensors, it had become a web of bright, thin seams. The three fingers closed on it. The material yielded just enough to allow a grip, like dense rubber. The arm lifted. The sphere held its shape, but the glowing lines shifted, running toward the point where the metal gripped it. It was as if the object were paying attention to the contact point, watching the machine that held it. Back on Earth, alarms started to trigger. The data link between rover and orbiter, and from orbiter to ground, carried a well-known set of signals. Telemetry, video, simple command acknowledgments. Now buried in that stream was something new. Blocks of bits that did not fit any defined protocol. They rode on top of the regular transmission, not interference, not noise. Structured, repeating. The ground systems flagged them as corrupt and tried to strip them out. The engineering team overrode that function. The strange data was the point. The old rover arrived at the crater just in time to watch. Its cameras showed the tiny micro-rover holding the black sphere at arm's length like a trophy. Dust tracks crisscrossed the rim. Two machines separated by a generation of design stared at the same thing in their own blind way. The operators turned the older rover's camera toward the object to get a different angle. For a second, both machines were looking at it. The sphere responded. The glowing lines brightened briefly and then dimmed. The data stream changed. On Earth, in a lab far from the noisy control rooms, a different team had isolated the new blocks of bits. They displayed them as raw binary, then as sound, then as images. At first, nothing made sense. Then one of the patterns clicked. It was a star field, crude, low resolution but recognizable, a cluster of bright points in a familiar layout. When overlaid on a real sky map, it matched a real region, not the local neighborhood, not a nearby star. A point a few hundred light years away that to human eyes was just another dim speck. To this object, it seemed important. The black sphere on the moon was, in its own way, calling home. They watched as the pattern repeated, shifted slightly, repeated again. Each iteration added a tiny variation, a kind of checksum or correction. The timing was precise. The gaps between bursts matched the light travel time from that distant star to here. It was not just pointing. It was negotiating, adjusting, syncing with something that from Earth could not be seen. The realization settled slowly. 3IAtlas had not simply shed debris, it had dropped a node, a relay, a device meant to land on a solid body, make contact with local machines, and then phone back. On the moon, the micro-rover's battery was dropping faster than expected. Holding the object, processing the new data, running every instrument at once was draining its reserves. The plan had been to collect the sphere and drive it into a shallow cave for longer-term study. That plan died under the weight of the numbers. There was time for one more move, maybe two. The options narrowed. Drop the object and save the rover, or keep holding it and squeeze out as much information as possible before the systems went dark. The decision was not hard in the room that had watched the glowing lines and the changing stars. They told the rover to hold on. The last minutes of its life were spent standing still, arm extended, black sphere in its grip, while invisible patterns pulsed through its circuits and out into space. On Earth, recording systems ran hot, storing every bit that came down. The old rover, with its simpler systems and slower mind, sat on the crater rim like an elderly witness. Its camera watched the younger machine until its image froze. The micro-rover's power bus finally dropped below survival threshold. One by one, its systems went silent. Video blinked out. Telemetry lines went flat. Only the strange extra data kept coming for a few seconds more, as if the sphere had noticed the loss and was finishing a sentence. Then, the stream cut. The object sat in the weak sunlight, half held by a dead machine, half buried in dust. Its glowing seams faded to black. To any future visitor with ordinary eyes, it would look like a smooth, dark stone in a small, forgotten crater. On Earth, the teams replayed the last transmission over and over, decoding, comparing, arguing. The mapped star field on their screens did not lie. Somewhere out there, in the direction the patterns had pointed, something had received a whisper from the moon. No one knew if it was the first whisper. No one knew if it was the last. They only knew one thing for sure. Now, whatever waited between those distant stars, if it did not already know about a small, noisy species around a yellow sun, it did now. They argued for days over what to call it. Some wanted to stick with a dry designation, a string of letters and numbers that would slot neatly into databases. Others felt that anything which had just spoken across hundreds of light years through a dead rover deserved a real name. The public has always solved it first. In forums and late-night shows, people started calling it the Lunar Seed. It fit the mood. Not a weapon, not a wreck, a seed. Something placed deliberately, meant to grow, or at least to connect. The scientists who hated poetic labels still used their codes and papers, but when cameras were on and microphones live, even they slipped and said seed. The old rover became an accidental hero. Its manufacturer released a quiet statement, noting that the machine had outlived its expected life by years. Fans online made tribute videos, editing together its long, slow journey across the moon into something almost like a retirement montage. The moment when it arrived at the crater and watched the younger rover's last stand became an instant icon. Artists painted it, kids drew it. Two robots on an alien desert, one dying with an arm outstretched, the other watching, while above them, an unseen line of information reached for the stars. No one had meant to create a story there. It happened anyway. Plans formed quickly to send another mission, a larger lander, a sturdier rover, maybe even a sample return system to bring the seed back to Earth. Each idea ran into the same wall: time. By the time hardware could be designed, built, launched, and landed, whatever conversation the seed had started might already be over. The star it pointed to was far, but not infinitely so. The light time there and back was measured in centuries, not millennia. If signals could bend that law through other means, through whatever tricks allowed 3IAtlas to dance through space the way it had, then any answer could arrive much sooner, or had already arrived somewhere humans were not yet looking. In classrooms, teachers tried to explain what it meant without frightening their students. They drew simple diagrams on boards. Here is our sun. Here is our moon. Here is the path of the comet. Here is the star far away. The seed is like a message in a bottle, they said, dropped on a beach we happened to be walking on. We did not write the message. We just picked up the bottle and held it to our ear. For some kids, it was the most exciting thing they had ever heard. For others, it was unsettling. One small hand went up in the back of one classroom in one city and asked the question that lived under all the others. If they planted the seed, does that mean they already knew we would find it? There was no good answer yet, only guesses wrapped in models and charts. Some said yes. The timing was too perfect. The presence of active rovers, the sophistication of human receivers, the growing web of telescopes able to see faint comets and tiny flashes on airless worlds, all of it pointed to a setup, a long-planned experiment waiting for the right conditions. Others said no. The universe was big enough for coincidence. Maybe the seed would have activated no matter what, sending its report back through regolith and vacuum with no one close enough to hear the echo. In that version, humanity had been lucky, or unlucky, to be in the right place with the right tools at the right time when an ancient message finally chose to leave the ground. The first real surprise came 3 nights later. Radio observatories around the world were still combing through the Seed's last transmission when a narrow spike appeared in a part of the spectrum that had been quiet for as long as humans had listened. It was faint, too faint to trip most automatic alert systems. One intern in a late shift saw it as a thin line on a waterfall plot. It rose, held steady for exactly 4.2 seconds, then vanished. At first, it looked like equipment noise. Then a second spike came. Same frequency, same duration, precisely 8 minutes later. And a third. There was no known terrestrial source at that band, no satellite scheduled to pass overhead. The direction matched the piece of sky the Seed had pointed to. The pattern did not carry obvious data, just on and off like a distant heartbeat. 4.2 seconds up, 4.2 seconds down. The interval matched rhythms seen before in other strange places, but here it felt new, fresh. This was not the Seed talking. This was something answering. Whether it was truly live, pinging back across impossible distances, or whether it was a delayed echo triggered long ago, did not matter in the moment. The important fact was simpler. The sky had changed. A star that had been radio silent now had a pulse. Weak, slow, but regular enough to set metronomes in quiet rooms all over the planet. The old rover on the moon, loyal and ignorant, went on with its scheduled tasks. It had no way to know that its smaller cousin had become famous, or that a tiny black object it could no longer see had started a rumor that would not die. It trundled along the rim of the crater, taking panoramas, measuring dust, listening to its own motors. In some frames, the Seed was a dark dot clutched in the frozen claw of a dead machine. In others, it was just a lump, half buried in glare. Future historians looking back through those images would say that this was the first time humanity photographed an alien device at rest. At the time, to the mission planners who still had to justify budgets and maintenance, it was just more gray rock and shadow. Stories spread faster than any data packet. People told their own versions over coffee, on trains, in comment sections. In some, the Seed was a gift, left as a test of curiosity. In others, it was a probe, tasting the moon and reporting back on whether this system had grown anything worth harvesting. Street artists painted seeds sprouting metallic vines over city walls. Songwriters slipped references into lyrics. One popular series of short videos turned the whole affair into a soap opera between the two rovers, complete with captions and imagined dialogue. It was silly, but it did something important. It made the whole strange business feel like it belonged to everyone, not just to the small circle of specialists with access to raw logs. In the quieter corners of the discussion, some people raised a different possibility. Maybe the Seed was not reporting on us at all. Maybe it was reporting on 3IAtlas, on where it had been, what it had done, what it had touched. The moon was just a handy rock on the path, a place to plant a black box recorder that could dump its memory up the chain to whoever needed the record. That reading made humanity feel both smaller and safer. Smaller because it suggested we were a footnote in someone else's mission log. Safer because if we were not the main subject, perhaps we were not the main target either. Like animals caught on a security camera meant to watch the door, time, as always, eroded the sharpest edges of the event. Weeks passed. Other news pushed in. Markets rose and fell. Elections came and went. The Seed sat in its crater, unblinking and unmoving. The distant spikes in the radio band continued, then faded, then returned at new intervals that did not quite fit any simple pattern. Research papers were drafted, rejected, revised, and quietly shared. A few dramatic claims leaked and were drowned in arguments. The world did not end. No fleet appeared in the sky. No beam lanced down to erase cities. Life went on. That was the strangest part for some, the idea that something so big could start and then simply wait. Yet in back rooms and late-night labs, the feeling remained that a countdown had started, not the loud kind with flashing numbers and sirens, a long, patient one written in the language of orbits and light years. Somewhere far away, information from a tiny black seed on a dusty moon was being absorbed, compared, weighed. To whoever or whatever had sent 3IAtlas through the dark, this data point would join billions of others. Maybe it would tip a decision. Maybe it would barely move the needle. Humanity had no way to know. All it could do, for now, was keep watching the patch of sky the seed had pointed to and the small crater where it lay, waiting to see which one blinked first.